Welcome back, Fun Nation, to Behind the Bumpers. Joining me today at the Greater Pittsburgh Regional is going to be Team 694 StuyPulse. They're coming off of a big win at the Hudson Valley Regional and currently ranked #1 at the Greater Pittsburgh Regional. Joining me today is Ellen, Rachel, Jaco, and Ian, and they're going to take us through their robot today on Behind the Bumpers. All right, Ellen, go ahead and take us through your funnel this system.
The funnel runs with one Kraken X60 with a 3-to-1 ratio, and we have belt wall on one side to prevent any jams and speeding up the intaking process. And on the bottom, we have an IR sensor right down here, so we can quickly detect when it's inside the shooter.
All right, awesome. Let's go ahead and feed a coral into this so we can see how this funnel works.
All right, now to the shooter. Just very simple, four sets of rollers. 2-inch compliant wheels, or 2.25-inch compliant wheels. If you guys can see here, we also have plates that extend out, which we call the Loki, which you can pick off algae from the reef. Everything's powered with double-sided belt. If you want to come here and see that. One thing you notice is that we have swerve tread on our rollers, and we actually tested that, and swerve tread was fantastic for that pickup. Another thing here, you can see on this plate on the arm, there's a small tensioner plate with bearings to tension this belt, because we noticed that for some reason the belt got really loose over time. Now up to the arm. This arm is driven with a planetary sprocket. If you want to come over here on this side. We're running a 30-to-1 reduction, and then if you can, we have an encoder, a rev encoder. West Coast Products encoders can come in time, but we have a rev encoder 1-to-1 ratio. The spline XL is fixed to the elevator plates. We did finite element analysis, and we noticed that the points of most strain are on this plate and also on the spline itself. So we beefed this plate up to 1/4 inch. It's been working fantastic for us, no big issues. And over here, there's also a small idler sprocket to tension the chain. Small little cam pushes it. Also been working fantastic. One thing you'd also notice is that we have our motors up here, which might confuse some people because it's higher, like you're raising center of gravity. But the reason of our choice, the reason why we put the motors up here is provide counterbalance, because it's on the opposite end of the pivot. Yeah.
And moving on to the elevator, this year we started using an internally rigged elevator, and the reduction is 50-14 with one Kraken X60. And we strategically place the belts inside the tubing so that we can utilize all these holes right here. And we have a physical hard stop that's 8 aluminum right up here. And then also what we noticed is that the elevator needs to be very structurally sound. So we have this A structure right down here, and we have half-inch head shaft with quarter 28 ball ends that physically pushes the elevator in the inside. So when the arm is moving and the elevator is moving up, the whole structure is very, very stable. Now moving on to the ground intake. This ground intake is able to intake the coral as well as the algae from the ground, and it can score the coral in L1, and it can score the algae into the processor. We have two motors, one for the pivot, which is a 48-to-1 gear reduction with a Kraken X60, and for the rollers is a 2-to-1 reduction with also a Kraken X60. And the special part about this ground intake is that we have a spline XL with a chain on one side so that these plates can revolute at the exact same degree. And we also added angles here on the mounting plates after we did a finite element analysis so that we can strengthen these mounting plates on a perpendicular axis to the plates. Now moving on to the climber. So this is a donut climber where we have a hole inside of a robot, and we have 2 pairs of climber hooks that push against the cage. And if you look at the geometry of the climber, we can show you with this. If you see the geometry of the climber, as it pushes down the cage, it goes from a larger radius to a smaller radius, so that after it climbs, due to the hard stops down here, these Lexan hard stops, the Lexan hard stops plus the weight of the robot as well as the gravity allows this climber hooks to stay in place and our robot to stay climbed even after we're disabled. So this allows us to not have an extremely high gear reduction ratio, as well as we don't need a ratcheting system. We also do not need a non-backdraggle system. So we were able to have a reduction rate 75-1, and we were able to climb really quickly by 5 inches off the ground from the ground to the wheel in a matter of half seconds.
We can also score backwards. We could also pick up algae from the reef. And should we show this part? This could score in the processor. We can also pick up algae with our froggy or our ground intake.
All right, that was an awesome run through of your robot, Team 694. Can we go ahead and talk a little bit more about the software that goes in behind making this robot work?
Yeah.
So this year, this is something that we experimented with over the off season, and we're carrying it over to the season now. We only have one driver, which enables us to have 2 human players. But what that means is our driver has to control this bot on his own, so we have to make it as simple as possible. We have to automate as many things so that the driver has less to think about. So all of those scoring motions that you saw, let me disable the bot real quick. All of those scoring motions that you just saw on the reef a second ago, those are all one button. It'll bring the arm to the correct state and the elevator to the correct height. It'll align and then score whenever it's ready. And to make it even more simpler, how the alignment works is it just picks the closest side of the reef, and it goes, by default, it picks the closest branch the closest branch to the robot, but the driver can pick left or right by moving the joystick left or right. We have a button for L2, L3, L4, and L1, and it'll just pick the branch that it's scoring on. If the front of the robot is facing the reef, it'll automatically score on the front. If the back, it's gonna score on the back. Another thing is, we really tried baby-proofing the robot this year because it's really easy to like break the arm on the reef, or let's say you're scoring L4, the arm is kind of above the reef here, and then if you bring the arm down too soon, it's gonna like start hanging on the reef. So what we did was we added clearances to make sure the robot could back up before bringing the arm and elevator down. That way the driver doesn't accidentally break the robot. So I'll show you that real quick. If we enable, and Philip, can you score L4? Enabling.
So go ahead and take us through it as it's operating.
Yeah, so Philip's gonna click one button here to score L4. And it automatically scored on its own. And notice how the arm didn't immediately come back down. It waited for him to back up before coming down. This way it wouldn't hang on the reef. And same thing for the other levels, L3 and L2. And so here's the cool thing that happened there. So in this moment, the robot was closest to this branch here, but Philip moved the joystick to the left, which made it choose this branch over here. So even though it was closer to this one, he could choose the branch over here. So that's the safety features that we have on the arm. For the froggy, this mechanism over here, if we try picking up a coral right next to the reef, so just stay here. If the froggy tries coming up, it's gonna hit the reef, right? So even though Philip has let go of the intake button, it's gonna wait until he backs up from the reef to come back up. So if you just back up, now we don't break that mechanism.
So all our central components are right below the funnel, which is very accessible. So here's the PDH and here's the Rio, and they're very, very accessible because we have this cover right here. And then going on to the limelight cooling system, due to overheating of the limelight, we were able to develop a cooling system in which there's a limelight, and then there's a thermal pad, and there's a heatsink and a fan that blows against the crevices of the heatsink so that the limelights were able to cool off very quickly. And because the system was very efficient, we also implemented it in the radio as well. So both the radio and the limelight are very cool.
All right, thank you to Team 694 for taking us through your excellent robot this year. Currently ranked #1 going into elims. Good luck in the rest of the event, and we'll see you next time. Thanks.